Acceleration. How we define acceleration? When the speed increase or increase in speed is known as acceleration. Acceleration of an object can be zero, it can be constant, it can be increasing, or it can be decreasing. So acceleration or increase in speed, it can be zero, it can be constant, it can be increasing acceleration, and it can be decreasing acceleration. These are the four possibilities for acceleration. So first thing, what is zero acceleration? What condition the object will have zero acceleration? So the term zero acceleration means there is no change in speed. If speed does not change, if there is no change in speed, we call the object is not accelerating, or object is having a zero acceleration. So if you have an object at different positions, speed of the object was 15 meter per second. At this point also the speed of object is 15 meter per second. Point B. Point C also, its speed is 15 meter per second, and point D, its speed is 15 meter per second. So if these are the different points A, B, C, and D. So moving from A to B, moving from B to C, and moving from C to D. What is the change in speed from A to B? So at A it was 15, at B is also 15. So if there is no change in speed, if the speed of object is not changing, what we call that object is having zero acceleration. So it will be 0 meter per second square. It is 15 at B and it is also 15 at C. Is there a change in speed from B to C? There is no change in speed from B to C. So it will be 0 meter per second square. Same thing, it is 15 at C and it is 15 at D. Again, there is no change in speed. So what we call that this object is having a zero acceleration, or this object is not accelerating. What will be the graph for this type of motion for a zero acceleration? Is it clear to everyone? The zero acceleration or no acceleration? So what will be the graph for zero acceleration or no acceleration? Speed time graph. If we sketch a speed time graph, on x-axis we have time and on y-axis we have speed. So you can see speed is constant, speed is not changing. So it will be a horizontal line. So speed is not changing or speed is constant. So it will be a horizontal line which shows that the object is having no acceleration or no change in speed. So this type of motion, when the speed is constant, there will be a horizontal line for a speed time graph which represent that there is no acceleration. Take the screenshot, then I'll move on to next part. If any one of you having a doubt or a question, you can either mention in a chat or you can use your mic to ask the question. Or if any part you want me to revise, I will revise that part again. Next is constant acceleration. What is the term constant acceleration? The term constant acceleration means that same change in speed. If change in speed is same, we call that as a constant acceleration. So you have objects at different points A, B, C, and D. The object was having speed of 10 meter per second. After 1 second, the speed changes to 15. Then it changes to 20. Then it changes to 25. So if I calculate the acceleration or change in speed here, so it was 10 changes to 15. So from A to B, what is the acceleration from A to B or change in speed from A to B? It is 5 meter per second square. The unit of acceleration is meter per second square. So it's 5 meter per second square. Then from B to C, so moving from B to C, that is also 5 meter per second square. Moving from C to D, again it is 5 meter per second square. So you can see the speed is increasing. The speed is increasing, but the change in the speed is same, or change in speed is constant. So we call that as a constant acceleration or constant change in speed. So if we sketch a graph for this motion, the speed and time graph. So time is on y-axis and speed is on x-axis. So speed is increasing, but with a constant rate. So when the speed increases with a constant rate, you sketch a graph. So there will be a straight line with a constant slope or a constant gradient. So this type of a motion, speed time graph, there will be a straight line, which shows that the speed is increasing, but its acceleration is constant, or acceleration remain unchanged. Is it clear? The constant acceleration. Any doubt in this? Then take the screenshot for this. This is for constant acceleration, which means the same change in speed. Yes, in the other word, you can say speed is increasing, but in a constant rate, at a constant rate. That's correct, Afif. If I say increasing acceleration, so the term increasing acceleration, an object, so what does it mean? It means the change in the speed will increase. So if you have an object at different positions, speed of the object was 5 meter per second, then it become 10 meter per second, then it become 25 meter per second, and then it become 50 meter per second. So this is point A, B, C, and D. So speed was 5, it became 10. So what is the acceleration when 5 changes to 10? It is 5 meter per second square. It is 10 become 25. So what is the change here? 15 meter per second square. So from C to D, C is 25, D is 50. So C to D, it is 25 meter per second square. So you can see here the speed is increasing as well as the acceleration or change in speed is also increasing. So what will be the shape of the graph for this type of motion? So it will be a curve and the slope of the curve will increase. So the graph for object which acceleration and speed both are increasing, so it will be curve and it will get steeper or the slope of the curve will increase. And the last part, take the screenshot for this. Any doubt in this concept of increasing acceleration? Then the last part is decreasing acceleration. There's a difference between decreasing acceleration and deceleration. The term decreasing acceleration does not mean deceleration. Decreasing acceleration means the change in the speed will decrease. But the speed will increase. So speed is increasing, but the change in the speed is decreasing. We call decreasing acceleration. So you have objects at different positions and the speed of the object at point A, B, C, and D. Say it was 10 meter per second. Then it became 20 meter per second. Then it became 25 meter per second. Then it became 27 meter per second. So if I say what is the acceleration from A to B, from B to C, and from C to D. So acceleration is the change in speed. So how much is the change in speed? It was originally 10, become 20. So acceleration is 10 meter per second square. It was 20, become 25. So what is acceleration? It is 5 meter per second square. It is 25, become 27. So it is 2 meter per second square. So you can see here the speed of object is increasing. There's increase in speed, but the change in the speed is decreasing. In the beginning, there's a greater change in speed, but with the passage of the time, the change in the speed is decreasing. This is an example of decreasing acceleration, but you don't say deceleration. This is not a deceleration, this is decreasing acceleration. Deceleration means the speed should also decrease, but here the speed is increasing, so we don't say deceleration. So if you have a speed time graph, for an object, this type of motion, the speed is increasing, there's an increase in speed, but acceleration is decreasing. How speed is increasing, you can see here, the speed is 10, the speed changes from 10 to 20. So if speed changes from 10 to 20, so you can see there's an increase in speed. But what about acceleration? The acceleration is a change in the speed. So the change in speed is 10. Same thing, speed was 20, the speed become 25. So if speed 20 become 25, the speed is increasing. But what about acceleration? The change in the speed is only 5. Same way, it is 25, it changes to 27. So speed 25 to 27, it means the speed increases. But what about acceleration? The change in the change in speed is only 2. So the change in the speed is decreasing, but the speed is increasing. In the beginning, there's a greater change, but with the passage of the time, the change is decreasing. Is it clear? So what will be the shape of the graph? Shape of the graph for a speed time graph, always the curve, the slope will decrease. So these are the 4 graphs for explaining the acceleration of an object. So acceleration of an object, which is a change in speed, it can be 0. So acceleration 0 here means the constant speed. This is when constant speed is increasing, but the acceleration is constant. Here the speed is increasing as well as acceleration is increasing. The last part, speed is increasing, but the acceleration was decreasing. So these are the 4 graphs which you should understand the concept of these graphs and explain what happened to acceleration of an object. Is it clear? Take the screenshot. I will explain the deceleration now. Next is the term deceleration. The term deceleration means decrease in speed. If the speed of an object decreases, we call deceleration. Same thing, deceleration can be 0, it can be constant, it can be increasing, or it can be decreasing. The object might have 0 deceleration, increasing, deceleration, or constant deceleration first, then increasing deceleration, and the last one is decreasing deceleration. 0 deceleration means no change in speed. So the graph for 0 deceleration or 0 acceleration having a same meaning. So if I say 0 deceleration, so the term 0 deceleration means there is no change in speed. Same thing, 0 acceleration or 0 deceleration having a same meaning. So if the speed of object does not change, we call that as 0 deceleration or 0 acceleration. Say an object was moving with 5 meters per second. After some time, it's remained 5. And throughout the motion, the speed will remain 5 meters per second. So at point A, it was 5. At point B also it's 5. At point C, 5. At point D also 5. What is the change from A to B? B to C and C to D. So from A to B, what is the change? It is 0 meter per second square. What is the change from B to C? It is also 0 meter per second square. What is the change from C to D? It is also 0 meter per second square. So there is no change in the speed. If speed of an object does not change, it means it has 0 acceleration or zero deceleration, or no acceleration, or no deceleration. So what will be the shape of the graph for this type of motion, the speed time graph? So if we have speed on y-axis and time on x-axis, so speed is not changing, so it will be a straight line. Straight line with a constant zero slope shows that there is no change in the speed. This is when the object is not having any change in speed or zero acceleration or zero deceleration. Take the screenshot for this. Same way, if we have constant deceleration, so the term constant deceleration means it's a constant change or decrease in speed. So you have an object and this object at position A, position B, position C, and position D. At position A, it was moving with 15 meter per second. At position B, it was moving with 13 meter per second. Position C, it was moving with 11 meter per second. Position D, it is moving with 9 meter per second. First thing, it's a deceleration because the speed is decreasing. So whenever the speed decreases, we call deceleration. But whether it is a constant deceleration or constant, so how you can identify? You identify the difference between the values. So from A to B, the deceleration was 2 meter per second square. The change was 2 meter. From B to C, the deceleration is also 2 meter per second square. From C to D, the deceleration is also 2 meter per second square. So all the points, the deceleration is constant, the same decrease in speed. So when we sketch a graph for time and speed, speed is on y-axis and time is on x-axis. First thing, the speed is decreasing, but with a constant rate. So when speed decreases with a constant rate, it will start with a maximum value and it will start to decrease. This graph shows that the object is having a constant decrease in the speed or same deceleration. Is it clear? So speed is decreasing and it's decreasing with a constant rate. That's why we call that as constant deceleration. Any doubt in this? Take the screenshot if no doubt. The deceleration can be increasing. So the term increasing deceleration, that the change, the decrease in speed increasing or increases. So speed is decreasing, but the change is increasing. Because the deceleration means decrease in speed. So there's a greater change in the speed. So if you have object at different positions at point A, B, C, and D. At point A, the object example was moving with 50 meter per second. At point B, it was moving with 45 meter per second. At point C, it is moving with 30 meter per second. And at point D, it is moving with 5 meter per second. So what is the change from A to B, from B to C, and from C to D? So when we calculate a change from A to B, that's equal to 5 meter per second square. From B to C, the change is 15 meter per second square. From C to D, the change is 25 meter per second square. So you can see the speed is decreasing, but the change in the speed is increasing. So decrease in speed, but the change in speed is increasing. We call that as increasing deceleration. So when we sketch a graph for this type of motion of an object, time and speed, so speed is on y-axis, time in a x-axis. So it will start with a maximum value, and then this will be the shape of the graph when the deceleration is increasing. Is it clear? So speed is decreasing, but the deceleration, the change in the speed is increasing. And the last part, take the screenshot for this. Decreasing acceleration, decreasing deceleration. So the speed is decreasing, and the change in speed will also decrease. So speed decreases and the change in speed will also decrease. We call that as decreasing deceleration. So object is at point A, it was moving with 50 meter per second. Move from A to B, it is 35 meter per second. From B to C, it is 25 meter per second. And from C to D, it is 20 meter per second. So when you calculate the deceleration, the change in the speed from A to B, from B to C, or C to D, what you will observe, the change was 15 in the beginning, meter per second square. The change was 10 meter per second square. The change is 5 meter per second square. So the change in the speed is decreasing. So we can say that because speed was decreasing, that's why we say deceleration. And the change in the speed is decreasing, so we say deceleration is also decreasing. So the shape of the graph for a speed and time so this will be the shape of this graph. It will start with a maximum value. In the beginning, there's a greater change. With the passage of the time, the change in the speed is getting less. So we call that as decreasing deceleration. So you should recognize these graphs because in exam, they in MCQs, mostly in MCQs, they give you an example like which graph represent increasing acceleration, decreasing acceleration, or constant acceleration or constant speed. So you should be able to recognize these graphs. So just a quick overview of these graphs. Take the screenshot. Look, first we discuss the distance and time graph. The distance time graph, the slope represent speed of an object. So if it's a distance time graph, the slope represents speed of an object. So if I say you have distance and time, and it is a horizontal line. Can you identify what is the slope of this line? The horizontal line. What is the slope of horizontal line? Slope of a horizontal line. So slope of horizontal line is 0. So if slope is 0, it means the speed is 0, because I told the distance time graph, the slope and the speed having a same meaning. If speed of an object is 0, if object is not having any speed, it means this object is at rest. So you can identify, just identify or recognize the slope, and using a slope you can tell what happened to the speed of an object. If you have distance time graph and there is a straight line which is starting from origin, what about slope of this line? What is the slope of this line? A straight line passing through origin. Whenever there's a straight line and this straight line is starting or passing through origin, what we call slope. What about the slope of this line? Slope means angle with x-axis. So slope is constant here. So if slope is constant, what we can say, we can also say speed is constant. So distance time graph, the slope represent the distance time graph, the slope represent speed. Same thing. Take the screenshot, then I will explain the remaining part. If you have a speed time graph and distance time graph. First is a distance time. So your distance time graph, and the curve is getting steeper. What happened to slope of this line? What happened to slope of this line?
Increasing.
So slope is increasing. If a slope is increasing, it means the speed is increasing. And the last part, if you have distance in time graph, what happened to slope of this line? The slope is decreasing, the last one. So if slope decrease, it means the speed is decreasing also. So these are the graphs for distance time. Either it will be constant speed, decreasing speed, increasing speed, or zero speed, or object is not moving, you can say. Then the calculations, take the screenshot. Then the calculation from distance time graph. So what we can calculate from distance time graph, we can calculate the speed which is equals to slope or gradient. And how to calculate the gradient? The formula to calculate gradient in maths also you will study this formula. It's y2 minus y1 over x2 minus x1. And it has two possibilities. If it's a straight line, it can be a straight line graph. It can be a curve. So if it is a curve, then what you have to do, you have to draw a tangent. I will share, this session will end in a short time, so I will explain this part in the next session. I'll share the link out once this will end.